Okay, this is the last and final lesson in the linear relations unit for Math 9. Today we're going to be going from graphs to equations. So we're going to be looking at a graph and then coming up with the equation that represents that graph. Just a couple of reminders of what we learned last day. We talked about the format that we're using for our straight line graphs. It's called the slope-intercept form because the y-intercept is the constant term. We usually call it b. So on the graph, that would be this point right here where it intersects with the y-axis. And then the value that's in front of the variable, we call it m, it's going to be the rate of change or the slope. So it's like how the pattern is changing over time. So just to quickly remind you as well, for the slope, talked about how it was the change in y over the change in x. There's a faster way or a little bit better notation. Instead of writing change in every time, I'm going to use this symbol, change in y, change in x. So that's a delta. It means change in, that little triangle. So change in y over change in x. Okay, so we're going to use the slope and the intercept to come up with the equations for these graphs. All right, so first, the easiest thing to spot is just the y-intercept. It's where it intersects with the y-axis. So that is going to be here, 3. And the slope is how this graph is changing over time. So let's look, you can pick any 2 points. I'm going to pick this point and this point. So if we look at it goes 2 down and 1 to the right. So the change in y over change in x is going to be, because it went 2 down, it's going to be -2, and it went 1 to the right, so 1. We can simplify this just to -2. So that's our slope. And so the equation is going to be y equals -2x plus 3. Always count, when you're counting out your slopes, always count in the direction that you read. That way you'll get the sign correct. So if you're counting down, it's going to be a negative slope. If you're counting up, it's going to be a positive slope. All right, so here in this question, the y-intercept is going to be -1. We can already write that down. And the slope is just how this is changing over time. So you can pick any 2 points. You'll have the consistent slope because it's linear. Let's pick these 2. And I'm counting up this time. 1, 2, 3. And to the right, 1, 2, 3, 4. So my slope would be 3 over 4. Change in y over change in x. Because I counted up, it's going to be a positive slope. Always count in the direction you read from left to right. Okay, so then my equation is going to be y equals 3 over 4 x minus 1. Sometimes students ask me, can I write it in the other order? Like, does it have to be 3 over 4x minus 1? Could it be -1 plus 3 over 4x? Yeah, it totally could be. You could switch it around. It's just by convention that we write it in this order, but you could also write it this way. Okay, last but not least, we can you could pause the video here and try this one on your own if you want, or do it with me. Here the y-intercept is going to be 0, and then the slope, we're counting down this time, so it's going to be negative. I'm going to pick any 2 points. I'm going to pick this point and this point, and I count 1 down and 1 to the right to get to the next point. So it's going to be -1 over 1, which just simplifies to -1. So my equation is going to be y equals -1x plus 0. But you would not see this like this in the answer key or in a book, or you probably wouldn't match your friend's answers either. When the coefficient in front of a variable is 1, we don't typically write it. We just leave it out. So we can write it like this, -x. And we don't really need to add on the 0 because that's not really affecting the equation at all. So we can just leave it as y equals -x. So the slope here would be -1, and then the y-intercept is 0. All right, let's go to the next question. This time we're going to do ones that are word problems. It's a little bit more challenging to figure out the slopes or the rate of change in these examples, so we need to pay careful attention. Let's do the y-intercept first though. So this one has a y-intercept that looks like it's right between 40 and 80. So the y-intercept would be 60. And then for the rate of change, remember you can pick any 2 points. So I'm going to pick this point and this point, and I'm going to look at what the change in y is compared to the change in x. Now for word problems, often the increments that the graph is going up by, or it's not going up by 1, so you can't just simply like count the squares like we could in the example above. We have to look at the actual values. So from here to here, I've gone up from 120 all the way to 140. So I've increased by 20. Or sorry, not 140, 180. Halfway between 160 and 200. So I've gone up by 60. And then my x values have gone from 4 to 8. So that's an increase of 4. So my slope is going to be always change in y over change in x. So it's going to be 60 over 4. Now for word problems, we also have units. So use the same units that are used for x and y in the graph. So my y value here, the units are dollars. So I'm going to use dollars. And my x value units are weeks. So I'm going to use weeks. So it's $60 per 4 weeks. And we can reduce that. 60 divided by 4 is $15 for 1 week. Or we can just write it as $15 per week. So if it's about a savings account, that means we're saving $15 every week, and we started at $60. So if I'm writing an equation, typically we would write it as like y equals, if this wasn't a word problem, it would look like this, 15x plus 60, but because it's a word problem, we want to use the variables that describe the graph. So it looks like on the y-axis we have the variable a to represent the amount of money we have. So it's going to be a equals 15, and then we're using the variable t for time, t plus 60. So this is a much better equation because it better represents or better matches the graph. But it has the same structure as y equals mx plus b equation. Okay, let's do the next two. I'm going to go a little bit faster this time. Okay, so this one, let's find the y-intercept. This is halfway between 800 and 1,000, so 900. And you could pause the video anytime and try some of these on your own. And then for the slope, we're going to pick any 2 points. I'm going to pick these two. And let's look at what the change in y is and the change in x. So it looks like it went from 500 to 100. So that means I decreased by 400 meters in the y variable. And then for x, I went from 5 to 10. So I've increased by 5 minutes. So the slope is going to be change in y over change in x. So it's going to be negative 400 because I had to count down for 5 minutes. We can reduce this. 400 divided by 5 is 80, so it would be negative 80 meters per minute. Or 80 meters per 1 minute. And the equation, it's going to be, we're going to use h for the y variable and t for the x variable because we're looking at height over time. So it's going to be h equals negative 80 t plus 900. And there you go. All right, last one. I encourage you to try this one on your own. We've got our y-intercept of 10 here. And the slope is going to be, we can pick any 2 points, doesn't matter which ones. I'm going to pick this one and this one. I'm counting up, so it's going to be a positive slope as I go from left to right. And it looks like I've gone from 30 to 50, so it'd be $20 as my change in y, and my change in x is from 5 to 10, so 5. So every time I go up by $20, it'll be 5 downloads. Or 5,000 downloads, but so it'd be 4 would be my slope. So my equation is going to be I equals 4n plus 10. I'm using the variables that are shown on the graph there. I'm just going to add the word 1,000. So it's $4 for every 1,000 downloads. All right. So when you're going from graph to equations, it always has the same structure. There are other structures, you'll learn them in the next course, but this one we're using here in Math 9 is y equals mx plus b. And then when you're doing word problems, it still has the same structure, but you're going to use the variables that are given in the graph. Okay, that is the end of the lesson.